concept, Beck, that we worked on? Kites, which are part of what family? Quadrilateral. Remember all those quadrilaterals we talked about? So now what I'm going to do is I'm going to put a quadrilateral on a coordinate plane. So I'm going to cover two different topics with one new thing. Right? I'm going to give you guys a coordinate grid. And I'm going to ask you to justify what shape that is. Now, what does it appear to be? A square. Okay, you could say, I think it's a square, right? Now, if you think that it's a square and it's on a coordinate plane, do you have any skills or resources you could use to prove that it is a square?
Yes.
So, before we get too far, what makes a square a square?
4 equal sides, 4 equal angles.
Okay, 4 equal sides and 4 right angles. So, is there something we do in geometry that could tell us the length of this line?
Yes.
What is that?
Distance.
The distance formula. Okay, so if I did the distance formula 1, 2, 3, 4 times and got the same number back each time, would that prove it's a square?
No.
It would only prove it's a
Regular.
rhombus. Okay, because remember 4 congruent sides is a rhombus. Now, how would I go about proving that it's got 4 right angles?
You just do
Find
the
the
like
extra
If it
triangles.
has a little grid and it just went straight on it, couldn't you just said it's a
You
right?
never assume anything in geometry. So, distance formula verifies lengths. What does slope do?
It's like the angle.
It's like the steepness of the line, right? But what if I have 2 slopes that are perpendicular? Perpendicular means it creates how many degrees? 90. So if I figure out that this slope is undefined and this slope is 0, are 0 and undefined perpendicular?
Yes.
So that would make that a 90-degree angle. That's kind of our process today. I'm going to put a shape on a graph paper and ask you to give me the most specific name possible for it. We're going to go through 3 shapes today. That's it. Just 3. They're tedious parts. I really want to avoid any cheating, right? And when I talk about cheating, I'm talking about doing this. 1, 2, 3, 4, counting things. Okay? Because we're going to do all of this today with numbers. Okay? Like actual coordinate locations. Tomorrow we'll do this with no numbers. With letters. You'll have to find the distance from AB to CD. With letters. Okay, you'll understand how that could be very hard. So if we practice these concepts with numbers, they become more simplistic with letters. So, things that you will use, the distance formula, they're in your notes so you can refer back to them. The midpoint formula, like, why would we ever use the midpoint formula? So how would using the midpoint help determine something is a rectangle?
You can see the diagonal by the
If the midpoints are overlapping, if the midpoints are the same, that means that they are bisecting each other. So midpoints will help determine bisectors. And what about slope? What is slope going to do?
angles.
It will do perpendicular if I have 2 perpendicular slopes, or will it do parallel? If you have 2 sets of sides that are parallel, what shape do you have?
Parallel.
A parallelogram. So let's start kind of basic. Just remembering the properties of those shapes. So what makes a scalene triangle a scalene triangle?
The sides are all not equal.
So no congruent sides. So a scalene triangle has all 3 sides that are different lengths. So what formula would you use to determine if a shape is a scalene triangle? The distance formula. What about an isosceles triangle?
2 sides.
2 congruent sides. What formula would you use to determine if a shape is an isosceles triangle? The distance formula. Is there any way we can discover anything about angles for an isosceles triangle?
If the sides are congruent, then the base angle is congruent.
But is there a way for us to
The slopes
will slope tell me angles? Yes. Only one angle though. What is the only angle slope determines? A right angle. So as you go through this process, can you say opposite angles are equal? Is there any way to prove angles are 60 degrees or 120 degrees?
No.
So we're really stuck with side lengths or right angles. Those are the only things that we can use to determine shapes. What makes an equilateral triangle equilateral? So this is the warm-up, right? The triangles is the warm-up. The main purpose of today is to get to these quadrilaterals. You want to start easy or start hard?
Hard.
Let's start hard. Isosceles trapezoid. What do you need to determine to prove that a shape is an isosceles trapezoid?
There's a set of parallel sides.
Okay, one set of parallel sides.
And the, what do they call the ones on the same side, or I don't know what the word is, but the ones, the angles over there.
There's no way to determine angles on the coordinate plane. Okay, I don't want to take that because it's not entirely correct.
Does it have to do with the slope of that?
No, you were the closest. One set of congruent legs. So when you say sides, it could be any side. When you say the word legs, it determines the pieces connecting the bases. So one set of congruent legs. So what you have to do is one set of parallel lines and then one set of congruent legs, the two pieces connecting the bases. Oof, kite, another really intense one.
There's the two sets of congruent sides, but they're like, I don't remember the word.
That's the word that we're forgetting.
Two sets of
Adjacent.
Nope, not adjacent. Starts with a C.
Corresponding.
Nope. CO. Two sets of consecutive congruent sides. So that's where we have two sides that are the same length and two other sides that are the same length. Two sets of consecutive congruent sides. No opposite sides are congruent. Right, now more of our layup shapes. What makes a parallelogram a parallelogram?
Two sets of parallel.
Two sets of parallel sides. Do you have to do anything else to determine that it's a parallelogram? That's pretty much it. If you can determine two sets of parallel sides, you're done. Rhombus. That's it. Four congruent sides. Rhombus has four equal side lengths. What about rectangle? Four right angles. I'm going to cheat. Super abbreviation. Four congruent angles. And then square. Four congruent sides. And four congruent angles. So here's how this is going to work today. You're going to draw a shape. You're going to plot points. And I need you to take your best judgment on what that shape could be and then start the process of proving that shape is the shape that you think it is. We're only doing 3 of these because they are very tedious, and you'll see that after the first example. So, something like this. Before your pre-AP brain goes crazy, there is one huge mistake people are making all day long, and I'm guilty of it too. Where is point A? Duh, Baker, it's at 3, 0. Right? How hard is that?
No, because 0,
Do
3.
you see how a mistake could be made? If you pull that point off the graph accidentally wrong, the rest of your math is irrelevant. That's an easy mistake to make. So where is A?
0, 3.
A is at 0, 3. If you calculate with the 0.30, none of your math's going to be right. Where's B?
6, 4.
Agree? We're all good there? And where's C? So I have my points listed, which is good to do because I have a reference to go back. Now, the process here is, what kind of triangle is that? Isosceles, equilateral, or scalene? You cannot make any justifications until there is some math on your paper. What's the math we're about to do? The distance formula. Now guys, this is just practice. You shouldn't be relearning this. I put it on your notes so you can reference the formula. There's a couple more conversations to be had about this as we go about it. So you have to find the distance of all three sides, the length of all three sides of that triangle. Where do you want to start? AB. So I'm going to start here at AB. So some tricks for using the distance formula. You have to know what it is first, right? But as you become more practiced with this, I always like to write my points stacked like that because it organizes my thinking. 6 minus 0 squared. Oh, don't jump ahead. Plus 4 minus 3 squared. At this point, you could use your calculator to go ahead and finish the problem. Right? You type it all in, and it comes out 6.08. And I'm fine with that today. But do you know how to work through the process by hand? Because you will have to do that tomorrow by hand. Your calculators are irrelevant tomorrow. So let's work through it. What is 6 minus 0?
6.
4 minus 3?
1.
6 squared,
36 plus 1.
which is
37.
the square root of 37. And then you have to ask your calculator what that number is, and it is 6.08. So the length of AB is 6.08. So after that process, how do you feel?
A little bit better.
Okay, not bad. So your calculator can do that for you, your brain can do that for you, or we can do that together. I like to go ahead and put 6.08 right there for the length of AB so I know where it stands. Options abound. You want to go AC next or BC next?
BC.
BC. So as we do this, it's easy for me because I can change colors. I'm looking at these 2 points right here. So the distance formula is, okay, you can do 6 minus 4. Is everybody confused about that? Does it have to be 4 minus 6? You can do 6 minus 4, but your next step has to be 4 minus 0. So it can be 6 minus 4 squared plus 4 minus 0 squared. 6 minus 4,
2.
4 minus 0,
4. 4. 16. And that equals square root of 20.
just me. Calculator Baker,
Yeah.
4.47. You're like, how does he know that? This is the third time I've done this today. Let's not kid ourselves. So that is the length of BC. So right now, what option is off the table? It cannot be equilateral. What's the last line we have to do?
AC.
AC. That's probably the hardest one to do because the numbers are so separated. Now we're doing A and C together.
So it's 4 minus
The square root of
4 minus 0
4 minus 0
square rooted
squared.
0 minus 3 squared.
Okay, now I'm going to be really picky about this. 4 minus 0. 0 minus 3.
-3.
Y'all see that? 4 squared?
Yep. That's 16
Negative 3 squared.
plus
9.
9. Plus 9.
Never get a negative number there. It's always going to be positive. 16 plus 9.
5.
Square root of 25.
5.
Alright, we reached the apex of the problem. All this glory just to say, didn't that suck? All that work and scaling. There's like nothing fun about that. I'm sorry. I mean, like, let's be honest. 5 scaling. So the whole answer is just the scaling triangle. It's really anticlimactic. Anybody else feel that?
Yes.
It's kind of like 7th period. No. Okay, so let's talk about some things that might happen in the future, that will happen in the future. Did I have to convert all these radicals to decimals?
Yes.
No. Is the square root of 37, the square root of 20, and the square root of 25, are any of those the same number?
No.
So you could have stopped there and said scalene, because they're all 3 different numbers, right? There will be a point in your life where you're not allowed to do this. The square root of 37 equals 6.08. The square root of 37 will equal the square root of 37. No decimals allowed. When we get here, the square root of 20 does not equal 4.47. The square root of 20 equals 2 square roots of 5. You have to start speaking in radical languages. The square root of 25 is 5. So when I tell you to simplify your radicals, like I can tell you simplify 2 squared. What number is that? 4. But can you simplify the square root of 9? 3. So it's becoming more inept at changing your numbers. So that stupid joke, why is 6 afraid of 7?
7, 8, 9.
Because 7 ate 9. But why did he eat 9? Did anybody ever ask that question? Why did he eat 9? Because he did 3 square meals a day. What's 3 squared? You're welcome. There's the next layer to that joke. And it keeps going, believe it or not. Okay? So, mission accomplished. Everyone's hooray. There's nothing fun about drawing a circumscribed triangle. There's nothing fun about it. And then here's the next layer. 2 more questions and we'll kill it. What could be the issue here? If you plot your points wrong. Yikes. So I'll give you a little bit of time. Good luck. Welcome back to 4th grade. Plotting points, guys. Don't screw it up. Was it 4th grade? No, it wasn't 4th grade. Let's just call it 5th grade. 6th grade? Last year? I have not done this correctly all day. Please make sure that you're labeling your points as you plot them. That's pretty important. If you want to connect the dots, please feel free. So if your shape doesn't look like that, you did it wrong. So the instructions say, name the shape. Pretty simple instructions. I'll go ahead and let you guys give a guess. What do you think it is? Parallelogram. I mean, that's not bad. So how do we go about proving that it is a parallelogram? What makes a shape a parallelogram? I have to prove that it has 2 sets of parallel sides. So how many times do I have to calculate slope in this instance?
Twice.
Twice. And you want to say 4, right? But do I have to calculate the slope of these vertical lines?
No.
Are these two vertical lines parallel?
Yes.
So check, check. I know that this QD over here and RS are parallel because they both have undefined slopes. So a little bit of a shortcut, but I am stuck calculating the slope of QR and TS. So how do you calculate slope? No. Y2 minus Y1 over X2 minus X1. That's on the front of your paper. I know you want to count it, right? You want to count it? You can't do that tomorrow. It will not work tomorrow. So, if I calculate the slope of QR, Y2 minus Y1. Over X2 minus X1, which returns a slope of -3 over +4. Does the slope -3 over 4 make sense?
Yes.
It's a negative line. Cool, check. So what am I hope, what do I get for TS?
The same.
The same thing. So we'll try with TS. Y2 minus Y1 is a very negative problem. X2 minus X1. -4 minus -7. 3. Uh-oh. -5 minus -1. Oh, yeah. Same. So I can say that shape is,
A parallel.
then you're wrong.
What?
You're wrong.
Rhombus?
Yeah, is a rhombus a parallelogram?
Yes.
So is it a rhombus? Do we check that? We didn't check that, did we?
We did not.
So what is a rhombus?
4
4 congruent sides. If you had proved it was a rhombus, would it have proved it was a parallelogram?
Yes.
So everything you just did, gigantic waste of time. Sucks. That's why you have to look at it and you have to make an adjustment, you have to make an assessment and stick with it. We made the wrong assessment. If I hadn't stopped you, would you have gone back and checked if it was a rhombus? No. So we can check for a rhombus. That's the distance formula. How many times? Twice. We can cheat here. This is not really cheating. 1, 2, 3, 4, 5. Cool? 5. 1, 2, 3, 4, 5. Yes. But unfortunately, I have to do
Distance.
the distance formula. Okay, so let's go ahead and try that. We need the distance between Q and R, which would be x2 minus x1 squared plus what? x2 minus 1. Trying to trick me? Not this decade. Again, right, so you can calculate that or you can mental math it. Anybody mental math that? After the first step, you should be able to. -1 minus -5.
It's 5.
2 minus -1.
It's 5.
So 4 squared is 16. -3 squared is 9. What is the square root of 25? 5. Are we on the right track?
Yes.
Okay, now let me give you a little bit of a shortcut. This is not going to work tomorrow. This is not going to work tomorrow. But it will work on your assignment. Okay? You understand the difference? This won't work tomorrow, but it will work on your assignment Thursday. A squared plus B squared equals C squared. Is that much faster? So you could do A squared plus B squared equals C squared. What do you think C is going to be? What number squared equals 25? So what shape is it? Look how tedious that is. Yes, that was one question. SpongeBob says 5 minutes later, or 5 hours later, 5 days later, whatever it is. Isn't that crazy? All that work just to say, what's the answer? Rhombus. Sucks. This is the last one. This guy right here, last one. Just me? I'm excited. Alright, plucked it. You already plucked it? What'd you get? Yeah, you did it?
No, I didn't do it. I just.
Oh, you plotted it. I thought you said you plucked it.
Oh, we're just skipping the 3.
We can go back and do it if you want.
No, I was just. I mean, no.
I feel like there's more bang for your buck on this problem.
No, that's just why I was confused. I was just curious.
I applaud your curiosity. Oh, Baker didn't do it. A, B, C, D. Who wants to stab a guess at what that is?
Square.
It's a square. So, if you're saying that it's a square, you have to justify that each side length is the same, and
It's a right angle.
you have 4 right angles. So that is 8 different calculations. That's the distance formula 4 times, and that is parallel perpendicular slope 4 times. So this will not work tomorrow, but will it work today?
Yes.
Let's cheat. Are you cool with that?
Yes. Yes.
Always.
So 1, 2, 3.
Yes.
1, 2, 3.
3 squared plus 3 squared equals
3 squared plus 3 squared equals 18, the square root of 18. Okay? Or 3 squared to 2. Let's try it over here. 1, 2, 3. 1, 2, 3. Is that going to return a different answer?
No.
1, 2, 3. 1, 2, 3. Is that going to return a different answer?
No.
Same answer. That's going to be the same answer on each different diagonal.
So it's a rhombus.
So I know for a fact that this piece, this piece, this piece, and this piece are congruent. But do you really know why?
Yes.
So they're each hitting the midpoint.
What? Say it one more time slower for me.
Because they're each hitting the midpoint.
Okay, so what kind of triangles are these?
Right triangle.
Now, could you say that side angle side is congruent to side angle side, which is congruent to side angle side, which is congruent to side angle side? So CPCTC says that all these 3 extra sides are all the same?
Yes.
Right? Who would ever thought? So really the assessment there is CPCTC says they're all the same. Once you do one and they're all the same, they become congruent. So we have 4 congruent sides. That shape is a rhombus right now. What's the one part that we're missing?
The
Angles.
Right angles. So they will only be right angles if this slope is perpendicular to this slope. 1, 2, 3. 1, 2, 3. That's up 3 over 3. That means the slope of this line is 1. Up 3 over 3. What's 3 divided by 3? Okay. The slope of this one is down 3 over 3. Well, the slope of this line is are positive 1 and negative 1 opposite reciprocals.
Yes.
Are they perpendicular?
Yes.
Okay, so I can do this. Boom. Okay, positive 1 slope, negative 1 slope. What goes right here?
Right angle.
Positive 1 slope, negative 1 slope. What goes right here? Negative 1 slope, positive 1 slope. What goes right here?
Right angle.
What shape is that?
Square.
That's a lot of calculations, isn't it? And we cheated our butts off. Crazy. Okay, so before you put that away, this is an important conversation. Are you ready? That purple quadrilateral is a parallelogram. Cool? What is that purple quadrilateral?
Parallelogram.
If it's a parallelogram, I need to know what are the coordinates of that vertex.
So in this question format, it will be this figure is a parallelogram.
It might be a trapezoid. It
Well,
might be a
if,
kite.
hold on, I have a question.
Yeah,
So
I knew.
A is a variable, then
No,
would
no.
that be -0?
No. A is the coordinate location of this point is negative AB.
So -0 B?
No. Negative AB.
So you can fill in A as 0, 0.
No. This is A. Oh, this A right here. Or this A up here.
Well, I was saying if they're both A. then
No,
it's
okay, so let me just. What is the coordinate location of this point?
0, 0.
Does that help?
Yes.
Yeah.
Okay, so let me get rid of that then. I was just trying to name the vertex as A. Because on your test, I mean,
What test?
on your test it says what is the coordinate location of T? So I need a coordinate location that T is at that coordinate. And there is only one correct answer. So you see how I'm saying I'm taking numbers away from you guys and we're speaking in general geometric terms. You guys can do this. You just never seen it before. So let me stair step you through this process. How long is this line?
6. 60.
Where are you getting a 6 from?
Because it's 6 units long.
Where are you getting the 6 from though?
Because the amount of times it moves across the x-axis.
Okay, that's a C.
Oh, then C. Like, I thought this was a 6.
Okay, so this is negative AB, 0, 0, negative C, 0, and question mark. Yeah, my bad. You're right.
You're fine.
Huh? So how long is this line? It is C units long. Okay, so let's talk about that. I'm standing here at the origin, and I move over C units. How far did I travel?
C units.
C units. Like G unit, but C units. But I moved C units in the negative direction. So I went C units to get here. That's called negative C. Right? How did I get to this coordinate location?
You went up A.
You went negative. You went A units to the side and B units to the up.
I went left A units, and I went up B units. Does it kind of make sense? So it's like saying I went X, Y, but I'm calling it negative A units this way, and positive B units that way.
So is
So-
it always from the origin?
Always from the origin, right? So how tall is this figure? How far up did I go to get here? B. So how far up did I go to get here?
B.
B units.
Oh.
Does that make sense?
Yeah.
Because it's a parallelogram, if this has a slope of 0, then this one should have a slope of 0. Right? So now we're stuck here. How far did I move in the X direction? That way.
C plus.
C plus A. So if I move C plus A units, I would go over C units, over A units, I wind up right there. Is that what you want?
No.
No.
Negative
Negative
C plus
CA.
negative
I went negative
Negative
C
CA.
minus A.
plus negative A's. So I went over negative C units and negative A units.
Yes.
So I can clean that up, and that's just negative C minus A. So the coordinate location of T is at negative C minus A, comma, B.
Would you not be able to do minus CA?
So if you did minus,
That'd be multiplication.
that'd be negative C times A.
Okay.
So if I put numbers to it, it's going to make uber more sense. Let's try putting some numbers to it. So what if there's an actual problem that you might see in real life? Right? Let's call A1. Let's call B2. Let's call C3. So how long is this line? 3 units. How tall is this line? So if I go up 2 to get here, I have to go up 2 to get there. Does that kind of make sense? Now I went back 3 units and back how many more? Back 3 and back. What is negative 3?
-4.
Does it work with this notation? What is negative 3 minus 1? So C is at the location negative 4, 2. So once you have that information, could you determine if it is a parallelogram?
Yes.
Yeah, so find the slope between negative C minus A comma B and negative A comma B. What is the slope of that line? Look at it, it's a flat line. What's the slope? 0. But can you calculate that with the coordinates? So x1, y1, x2, y2. y1 minus y2. Is it x2 minus x1?
Yeah.
What is 0 over anything?
0.
So the slope is 0. Isn't that crazy how it works out? The slope is 0, but there are no freaking numbers that will support that. You want to try an easier one? That was like super hard. Let's go for an easy one. This shape is a square. Okay? This is the location A0. This is the location 0B. What are the coordinates of this location? Over A, up. Look at you guys. You can do it. That's not that bad, is it? So tomorrow we'll start baby stepping you guys through this, and then we'll finish with a proof. A proof with no numbers. Here's what your proof looks like. Verify that this is a midsegment with no numbers. And you're going to see stuff like this. Oh, it's going to be great. Or however, like, it's not accurate, but it's something like that. It's going to be awesome. So tomorrow is no numbers. You have no homework tonight. You're going to have no homework tomorrow.